So yeah, Marchin from Open Source Ecology was wondering about, with our 3D printers, do we find that we generally get issues when we get to the top of our prints? That you know, because of the bed moving, that you get problems with that. And how do we rectify it? Do we witness this problem less with the printers the current design that we're looking at?
Yes. Yeah. Most of the problems are not when you get too tall. Most of the problems happen around an inch, like a couple of centimetres tall.
Okay.
Once you start getting off that heated bed to the point where your plastic's cooling, it's not getting kept hot by the bed, that's where your problems start.
Okay.
And to overcome it, it needs some sort of an enclosure to keep all the plastic at the same temperature.
Okay.
Or as close as you can get.
And outside of that, vibration could also be the other issue that mucks up prints at the top. Is that correct?
I'm not sure exactly what issues you're talking about.
Yeah.
But
well, that maybe it's that when you prints start to get up to the top, that
the bed moving backwards
and
forwards
the
and
momentum
things.
of the object itself.
No, I've made some pretty tall objects with intricate things like dragons with big wings and stuff, and you do see a lot more lines when you get up.
Okay.
That can be solved by slowing down.
Yeah.
So it's a speed
Putting
thing.
that into your control software.
Reducing the momentum on things like your carriage is moving, so it's not pulling the printer backwards and forwards. And so I've worked on that. Instead of using 6mm aluminium plates as a heater bed, only using 3mm. Instead of using a solid plate, I've got lots of holes in there. So I'm only moving.
Can you explain that? I don't quite grasp what you mean.
Okay, so your heated bed is it's a piece of glass
say 20
with
by
a circuit
20.
board and an aluminium plate below it.
Yep.
That all adds up to about 700-800 grams.
Yep.
So you've got this 3/4 of a kilo mass going backwards and forwards, backwards and forwards, backwards and forwards, and it makes the printer tilt. So you stop that by having braces on your printer so that it can't move back. So if the whole printer wants to tilt back a little bit, it doesn't matter. But if your frame's flexing because of that momentum, it'll cause
the
problems.
rigidity in the frame is the issue.
So you can print slower. You can have a more rigid frame, but the frame is about as rigid as you can get. It can be made more rigid just by adding more material.
Yeah. But currently what we've got is about as rigid as we can get. And it's significantly more rigid than most of the 3D printers out there.
It's the best i3.
Yeah.
I can't think of a better frame design out there.
What about the ones where the bed is not moving?
Definitely. Okay, if your bed's not moving, you've got but I think it's a lot more complexity. Like
the mechanics
gets
get
expensive.
complex.
It gets a lot more expensive because you need a whole exoskeleton then, and everything's got to work inside, rather than just having a stable X and Y axis and working around that axis.
The cheapest way to make a stationary bed printer is a Delta. And those things are a complete pain in the ass to calibrate. You do not want to be doing that as a first printer.
No, I think they're also so limited in terms of the bed size compared to the freaking height as well. Like the bed sizes, I've never seen a really big Delta printer that wasn't huge.
Well, I've got a plan for a Delta where the bed is the same size as an i3. I think it's 600mm diameter.
Yeah, it's not newbie material.
No,
it's not easy.
No, it's not. It's not my first 3D printer. No, definitely not. Maybe my second 3D printer. The first one should be a moving bed Cartesian, like your design.
I can't think of a better first printer. From all the designs I've seen, I've never been tempted to go anywhere else yet.
Yeah, they're so bloody simple. Unless you do something really strange, like put on a 0.25 nozzle, then it's really obvious what the issue is when there's an issue. Like if your print's shifting over to the right, then you know you've got a problem in the x-axis. If it does that in a Delta,
diagnosing
it could be
problems
anything.
is so much easier. Exactly. Yeah.
It's just a straight mapping A to B. This problem, this solution, 1-to-1. Whereas with a Delta, it's like, well, any problem. Well, your rod length might be wrong, or maybe your tower radius, or maybe the effector, or maybe this, or maybe that. Anything could be anything.